So welcome back. So we were dealing related to the inherent problems in any measurement. So the second methodology is nothing but the actual calibration service what we follow. You will measure a known standard material and check out the force value of it. You will replace that standard material with the actual material whose force measurement has to be done. Then you compare so that you will overcome the inherent problems which are associated in measurements. So these are the things what you have to understand before we go for modifying and terminating devices. So one is what you mean by mechanical system, and other one is the inherent problems in any measurement which come across. Okay, so this force measurement system what we follow in calibration has two parts. So one is sensor या signal producing system and other one is the indicating system. So sensor or the signal producing system, what does it do? These are measurable attributes. So the magnitude of it will have a correspondence to the magnitude of the applied force. So in the sensor or the signal producing system is nothing but a detector. So how does it sense? It senses depending upon the magnitude of the force being applied. If you are using a good pressure sensor or any other sensor, so that clearly senses the amount of force applied, and the same amount of magnitude of the corresponding force data will be originated in the input signal. So these are measurable attributes which directly are connected with our input signal. The second one is indicating system. So what happens in indicating system? It quantitatively display the signal from sensing system, right? It displays the signal from the sensing system and it is essentially a black box. So what do you mean by it? You have a detector which is nothing but a sensor which will sense the applied force. So the sensed input signal will be displayed quantitatively, and that display in which it is being done is essentially an black box. It is an device which displays the data read. So it will be in our modifying unit, what we call that as modifier or second stage transducer elements. So to do this indicating system, there are different types of electronic indicating systems which can be used with strain gauge type sensing system. So in order to work out, you should be using a strain gauge type of sensing system which senses the applied force, and that applied force will be displayed using a black box which is nothing but our electronic indicating system. Okay, so these system will be having provisions to zero adjust, amplify the gain, adjust, okay, based on the particular load applied. So what does this do? So you should understand there are three stages. One is the detector stage in which the sensor plays a vital role, and second is the indicating system which is the intermediate stage which will amplify the received input, and it displays the received input signal irrespective what input signal it has been taking. So these input signal, if it has to be converted into an output, it has to be modified. For that it should be having some adjustments with it. So these adjustments are nothing but zero adjust or amplifying the received gain with respect to the particular load. So everything, this adjustment depends upon the load applied. So based on the load applied, it will be sensing the applied force. So based on the applied force, it will display it in the modifying unit which is a black box. So there are different varieties in order to display in an indicating system. These will be working out very good if you use a sensor which is of strain gauge type. So it has a modifications to enhance the display which are nothing but the zero adjust, amplifier gain adjust, which mainly depends upon the load applied. So these are the two type of force measurement system what we use in calibration service with respect to our transducers. So we are relating everything related to our transducer elements for our modifier and terminating devices. So based on this concept, now we have to come out for intermediate modifying and terminating devices. I have told you this. So this is the modifier unit and this is the output unit. Stage 2 transducers and stage 3 transducers. So what happens in case of intermediate modifying and terminating devices? So in most cases, mechanical quantity which was detected will be transduced into an electrical form. So what does a mechanical transducer does? It absorbs a physical quantity and convert that into the required displacement. So these mechanical quantities which are detected will be transduced in the form of electrical form. So it could be an voltage or an electrical signal before it is fed to the third or terminating stage, because stage 1 will sense and it converts into the displacement. So displacement comes into the modifying unit which has to modify, do conversions based on these adjustments and finally transmit that to the terminating stage. So terminating stage will be nothing but our indicators, recorders or control elements. Indicators, it will indicates the reading directly, it will record the output, or the control elements can directly transmit that into the next device which needs an output. So this is basically how an modifying and an terminating device works. We have explained this with respect to example also, Bourbon tube and all, if you remember. Right. So now you have to understand the signal conditioning equipments can be used for mechanical, electrical or electronic type of transducers. This signal conditioning is the thing what you have to understand. So irrespective of any type of transducers, this signal conditioning equipment can be used. So if it is mechanical types, the elements used could be linkages, gearing and cam etc. in order to get the required movement in the displacement. Okay, so these mechanical types have many limitations because mechanical types will be having elements which are movable. So due to moving parts, it has its own limitations because it helps in resulting friction, inertia, non-linearity, backlash and elastic deformations. All these we have dealt already. So in comparison to the other two, in comparison with mechanical, electrical and electronic type of transducers are more feasible because it has less drawbacks and also large amount of voltage and power amplifications are required to drive the recording devices. So we use electrical and electronic in order to overcome these drawbacks, but these electrical and electronic systems are associated with some other factors because they need large amount of voltage and power amplifications are required in order to drive their recording devices. Sorry. So the mechanical signals transduced into electrical signals are not only amplified but in special types. Okay. So usually the work is nothing but the mechanical signals are sensed and it has been converted into the electrical signals. And they are not only amplified but in special types. Signal conditioning may involve filtering, integration and differentiation. So what do you mean by it? It helps in converting and it also amplifies the signal. Along with that, it helps in signal conditioning because it overcomes in filtering. It will integrate if you have many parameters coming together, and it can differentiate also electrical signal based on the requirement. So you have a fine tuning of the output data what you are receiving. That is mainly due to signal conditioning. And this signal conditioning equipments are mainly depends upon which type of elements you are using, either mechanical, electrical or electronic. So depending upon the applications needed, you can go ahead with mechanical elements, yeah, electrical, yeah, electronic elements. So we have dealt related to all the three types. So this is a simple current sensitive circuit. So how does it looks? So you will be having an input voltage which is being passed through the resistance transducer. This is a passive type of resistance transducer, so it is not an active type. We explained both the active and the passive resistance. So this is the passive type of the resistance through which the input voltage will be made to pass through. So when it has been passed through, it will have an indication of value of the resistance in it, and the resistance of the transducer changes when there is a change in the physical quantity being measured, because it has its own passive resistance value. So when you input an voltage passing through it, so there will be change in the passive resistance of the measuring element, right? So the resistance of the transducer changes when there is a change in the physical quantity being measured. So thereby it causes a change in the current which flows in the circuit. So whenever you have the voltage V is equal to Ri, right, the equation what we follow, voltage is equal to resistance times of the input current. So based on the voltage you apply, if you make it to pass through the passive type of resistance system, then the change in the input current will be indicated and sensed by using the current indicator, which provide you the output current based on the passive resistance you are using. So here we refer R suffix T as maximum resistance of the transducer. So we are using an passive resistance material here. So what is the maximum resistivity of that transducer will be referred by the letter R suffix T. Then you should know what you mean by K times R suffix T. So it will be the resistance of the transducer when measuring a particular value of the physical quantity. So it mainly depends upon the physical quantity of what material you are referring, because K represents the percentage factor which varies from 0 to 1. So you will be multiplying the percentage factor from 0 to 1 depending upon the physical quantity you are using to measure the resistance of the transducer. So R suffix M will be nothing but the resistance of the measuring circuit, excluding the transducer, because you have a resistance type transducer and you have a passive resistance material. So if you include the resistance type transducer resistance also, the value of R will be different. So you have to exclude the resistance of the resistance type transducer to get the value of R suffix M. Okay, So it is the resistance of the measuring circuit excluding the transducer which is in the input circuitry. And K, I have told you, it represents the percentage factor of the physical quantity what you are measuring. It usually ranges from 0 to 1. So based on these concepts from our basic Ohm's law, the current flowing through the circuit means the output current which is flowing through the circuit will be equal, which is indicated. Okay, so the output current which flows in this input circuitry, this is our input circuitry. So the output current which is flowing in this input circuitry, based on Ohm's law, what we get in the indicator directly, the measurement will be based on this theoretical equation, which is E suffix I divided upon K into R suffix T plus R suffix M. So E suffix I will be nothing but our input voltage divided upon the percentage factor K multiplied into maximum resistance of the transducer. Uh, just bear for a few minutes. So finally, this will be the input voltage divided upon the percentage factor into the resistance, into the maximum resistance of the transducer what we are using, plus the resistance of the material excluding the transducer, because in this input circuitry we'll be using a resistive type of transducer. So one is the maximum resistance of this resistance type transducer, the other one is the resistance of the input circuitry excluding this transducer. So this will provide as the output current which is passing through the input circuitry for any electrical device. So this is the simple circuit sensitive system what you have to understand. So the maximum value of the current occurs whenever the value of K is 0. So it represents a percentage factor which vary from 0 to 1. So it depends upon the transducer element what we are using. If you are using a transducer element which has consistency in its value, so this value will not be varying. So whenever the value of K is the least, you will get the maximum in output current. So then the equation you can rewrite as input current upon the resistance of the passive element, passive resistance what we are using. So you can rewrite I naught by I max is equal to R suffix M. So if you fine tune it with the calculation, you'll come to this finally. So this will be Rm upon Rm plus K into R suffix T. So now if you take again Rm as a common thing, so this will be 1 plus K into RT divided by Rm. So this provides the ratio of input current to that of the maximum value of the current. So this variation, the figure shows a variation of I naught by I max ratio with K for various values of RT by Rm. So based on the resistivity of the transducer and the passive material, the I max and the I naught value changes. So where I naught represents the output signal, K depends upon the input signal which has been sensed, the physical quantity what you are sensing, and the physical element what you are sensing, and hence it represents as an input data. K is referred to as an input data. And here the figure also shows the input output relation variable. So you have the graph. So after you get the value of I naught, if the value of K is 0, then you will fine tune the equation in such a way you can find out the variation of input current to the maximum current. Then you will find out the values for all the experiment data what you have done. So you will show the ratio of I naught and I max for the value of k, which ranges from 0 to 10. So this 0 to 10 depends upon the physical quantity which is being sensed as an input signal. So based on the physical quantity sensed, you will be getting the variable 1, 2, 3, 4 until 10. So based on these values, you will plot the graph for I naught by I max. So this is the value which is maximum when k is equal to 0, and it comes reducing when the value of k is increasing from 1 to 10. So this will be again depending upon our RT by RM value. So this is how you will plot the graph and show the variation of the output current with respect to the input signal what you are receiving for any physical quantity for which the value of k varies from 0 to 10. So this is of the variation in the output current what you get in a current sensitive circuit. The same thing is been explained over here. Okay, so in the tomorrow's class we will deal up with respect to the ballast circuit, electronic amplifiers, vacuum tube amplifiers, what do you mean by telemetry. Okay, telemetry transmitting and receiving systems we do have, and finally we have terminating devices. In this you should also understand mechanical counters and finally cathode ray oscilloscope. So all these we will deal it up in tomorrow's class. And everyone, if you have any doubt you are free to ask, and I will take a screenshot again for the attendance. In the meantime, if you have any doubts, you're free to speak. And if anyone have not written your name in the chat room, kindly do type it out. Any doubts? If anyone have not written your name and USN, kindly type it out. Please don't go out of the house without any reason. Stay safe at home. Do useful work positively. See the best how you can extract until and unless the college is open. So anyone else, if you haven't written your name and USN, kindly do type it. uh, Princess here, hello. Nihal,
Yes.
Alap,
Yes, ma'am.
Chinmay,
Yes, ma'am.
Pranay, is not there. Tarun,
I'm
Yes,
okay.
ma'am.
Ibad, Ashitesh, Vivek,
Ma'am, both present.
okay. Vivek, Ashitesh, Ritik. I'll come to know how many are really listening.
Yes, ma'am.
Ritik,
Yes,
Narendra,
ma'am.
Narendra,
Present, ma'am.
Jayant,
Present, ma'am.
Darshan, Shravan,
Yes,
Siddharth,
sir.
Shivam. Both the
It's Siddharth,
Siddharth are
ma'am.
present, right? Both the Siddharth.
Uh, yes,
Yeah,
ma'am.
yeah. Shivam, Shivam, Sautrik Roy, Akshat,
Yes, ma'am.
yeah, Akshat,
Yes, ma'am. Yes,
Sanjay, yeah, Sanjay
yes,
Oda,
ma'am.
Prayag,
Yes, ma'am. Yes, ma'am.
Yeah. Prayag,
Yes, ma'am. Yes, ma'am.
Chaitanya,
Yes, ma'am.
and Milan.
Present, ma'am.
Okay. Oh, Darshan is there and his mic is not working. Fine, done, no problem. So everyone, take care. Have a nice day. We'll meet you tomorrow again. Bye bye. Take care.